Here we want to find the local maximum and local minimum by using the first derivative test and also by using the second derivative test of the function f of x equal to x cubed minus 9x squared minus 48x plus 52. Now, to find local maximum and local minimum, first we will find a critical point. Critical point, it's possible to be a local maximum or minimum. To make sure they are local maximum or minimum, we'll have to apply the test, either the first derivative test or the second derivative test. Here we'll apply both. So first, let's find the critical point. So critical point is where the first derivative is equal to 0 or where it is undefined. So here I'm taking the derivative first. Now this is our derivative. This is just using the power rule. Now I'm gonna factor the 3 out and gonna be left with x squared minus 6x minus 16. Now f prime of x is 0, gonna be 3 multiplied by x squared minus 6x minus 16 equal to 0. And we're left out by x squared minus 6x minus 16 equal to 0. Now we want to factor this term, so what I'm gonna do, I'm gonna find two numbers that if I multiply them, the result will be minus 16, and then if I add them, it's gonna be minus 6, which is the middle term. So these numbers gonna be plus 2 and minus 8. When I multiply these two, gonna be minus 16, and gonna add them, gonna be minus 6. So it's gonna be x plus 2 and then x minus 8 equal to 0. Now we'll have x plus 2 equal to 0 and x minus 8 equal to 0. Now in case of x plus 2 equal to 0, x gonna be minus 2, and in case of x minus 8 equal to 0, we'll have x equal to 8. Now these are our critical points. Again, our critical points are minus 2 and 8. So now what we're gonna do, we're gonna apply the first derivative test to determine what is a local max, which point of these are a local maximum and which point is a local minimum. So first I draw a number line and point the critical point on the axis, and then I'm gonna figure out the signs of the first derivatives. So what I'm gonna do, I'm gonna pick numbers that is larger and lower and between these critical points and evaluate them at the first derivative to figure out the signs. So what did I wrote here on the left? This is just f prime of x, what we found previously. So I'm just here picking some numbers randomly. The middle gonna be 0, and then to the left minus 3, and to the right gonna be 10. And then again I want to find the signs at these values at the first derivative. So I'm gonna just plug here minus 3 to the first derivative, gonna 3, and then minus 3 plus 2, and then minus 3 minus 8. This term in here gonna be minus 1, and this term gonna be minus 11. If multiply negative by negative, it's gonna be positive. So here it's positive, and then f prime of 0 gonna be 3, 0 plus 2, and 0 minus 8. This term gonna be, so negative multiplied by positive, it's negative. And then lastly, our third point, f prime of 10 gonna be 3, and then 10 plus 2, and 10 minus 8. The first term gonna be positive, and the second term also gonna be positive. So a positive by positive is just positive. So now I'm gonna put these onto our number line, and at 10 it's gonna be a positive. So what we notice at x equal to 8, the derivative is going from positive to negative, and then at 8 it's from negative to positive. So that means at x equal to -2 there is a local maximum, and there at x equal to 8 there is a local minimum. So now what I'm gonna do the same thing but using the second derivative test to see what's a local maximum and what's a local minimum. So again, our critical points in here are -2 and 8. And our first derivative is 3 multiplied by x squared minus 6x minus 16. Now I'm going to take the second derivative, which is 3, and then multiply by 2x minus 6. This is just applying the power rule. Now, the second derivative test saying we have to evaluate our critical points at the second derivative. We want to see what are the signs of our critical point evaluated in the second derivative. So we'll start with -2. It's gonna be 3 and 2 multiplied by -2 minus 6. It's gonna be -4 minus 6. It's gonna be -10, which is just negative number. Here we just care about the signs, we don't care about the value. And then we'll do the second critical point. So 3 multiplied by 2 multiplied by 8 minus 6. 2 multiplied by 8 is 16 minus 6, which is a positive number. So what does this mean? So at x equal to -2, the second derivative is negative actually, and then at equal to 8 is positive. If the second derivative is negative, meaning it's concave down, and when it's positive, it means concave up. So there are the shapes of concaving up and down. So in concave down, what we see in the shape, there's a local maximum. Therefore, at x equal to -2, there's a local maximum. And then at x equal to 8, we see the shape is concaving up. Therefore, we can see there's a local minimum. And this is the same thing we found in the first derivative test. Now if we graph this function of x, we can see clearly that at -2, here, there's a local maximum, and there at 8 there is a local minimum.